Good morning, Blue Streaks. This morning I'm going to go over the practice quiz with you and hopefully answer any questions you have, as well as then post the quiz that will be due tomorrow, which will be Thursday, the 16th of April. So let's get started. Number one, we want to find the 6 trig ratios for that corresponds to this 0.23. So we have to draw a right triangle from the 0.23. So what we do is draw our triangle first. So our x value side is going to be 2 units, and then our y value side will be 3 units. And then from that point, we'll draw a line back to the origin to get our right triangle. So our right angle's always out here by the sorry about that, by the x-axis. Okay, so this side will be 2 units, and this side will be 3 units, because that point right there is the 0.23. So from that point, we draw a line back to the origin for our hypotenuse, and then this way's 2, this way's 3. There's our right angle. Always put your right angle there. Right, theta will be always the back there by the origin. That's our reference point, our reference angle. So before I can answer and find those 6 trig ratios, I got to find the length of the hypotenuse. So that's when I use the Pythagorean theorem. Okay, so I'm going to go 2 squared plus 3 squared equals c squared. That's the Pythagorean theorem. A squared plus b squared equals c squared. All right, so that's 4 plus 9, which is equals our c squared. So take the square root of 13 to get our c value. So remember, don't forget to take the square root. So this side is the square root of 13. Now I can find those 6 trig ratios, okay? Remember, SOHCAHTOA. Sine of theta will equal opposite. There's theta, opposite's 3, over hypotenuse, square root of 13. Now, some of you have been leaving that like that. We can't do that. You have to rationalize your denominator. So don't forget that on the quiz. So our answer is 3 radical 13 over 13. And some of you are forgetting the other 3. So I always do the reciprocals right away. The reciprocal of sine is cosecant CSC of theta. Just flip that original fraction, this one here, square root of 13 over 3. Okay, then we'll do the cosine. All right, ka, SOHCAHTOA. Ka is adjacent over hypotenuse. So here's theta. Adjacent is 2. Adjacent side over hypotenuse, square root of 13. We're going to rationalize again. I'm not going to show all that work. It's going to be 2 times the square root of 13. Oh, sorry. Should have been a 13 there. Over 13 here, too. All right. And then secant is a reciprocal of cosine, SEC. And again, we just flip that original. So it's a square root of 13 over 2. And then the last two are tangent and cotangent. And TOA, remember, SOHCAHTOA. Tangent is opposite side 3 over adjacent side 2. So cotangent, which is COT, would be 2 over 3. So there's your 6 answers for number 1 on our practice quiz. The next one, number 2, is we're finding the measure of the reference angle for 142 degrees. So what I like to do is draw it real quick. Make my Y and X axis. And remember, when I'm going this direction, that's the positive direction. Okay, up here is 90. And here's 180 going around. And then 270 and 360 is all the way around. Okay? So, if we're drawing this angle in standard position, we start here on our initial side, and then we go over, and then we rotate around to the term. So that's 142 degrees there. So that's what it looks like. Now, we're looking for the reference angle. The reference angle is always between the x-axis and the terminal side, and it's always a positive number. Okay, so I'm looking for this angle here in that area. Okay, so the way, since that's 180 and that's 142, to find that angle there, I have to subtract 142 from 180. And that'll give me 130, I'm sorry, not 138, but just 38. It's always an acute angle, less than 90, and it's always positive. So that's 38 degrees for that reference angle. Number 3 was coterminal, all right? All right, we were supposed to say, find the measures of a positive angle and a negative angle that are coterminal with negative 150 degrees. So all you do is you add 360 and you subtract 360 from that, and you'll get a positive coterminal angle and a negative. Now, if this number is greater than, if it's smaller than negative 360, you're going to have to add 360 twice or more times till you get a positive. And if it's more than 360, you might have to subtract 360 a couple times to make it a negative. So some of you are adding and subtracting 180. You need 360. All right, when you add 360, you get 210 degrees. There's my positive. And when you subtract 360, you get negative 510 degrees. So those two are coterminal to negative 150. Number 4 is the picture, and it just says find the value of the sine, cosine, and tangent. All right, so this is only 3 answers. So the sine of theta is opposite 4 over hypotenuse 5. And then cosine of theta is adjacent 3 over hypotenuse 5. And then tangent of theta is opposite 4 over adjacent 3. Opposite over adjacent, okay? So again, SOHCAHTOA, easy problem. Okay, 135, we're drawing this angle in standard position. Remember, counterclockwise is positive degree measures. Clockwise is negative degree. This is positive. We always start again on this initial side, which is the x-axis from the origin. And then we rotate around. Remember, that's 90, 180, so 135 is about halfway between. Draw a little arrow or arc, and we just label it. So whoever's looking can tell how many degrees are you trying to show. So that's all you have to do for that. Just drawing an angle in standard position, 135 degrees. Okay, number 6 is another 6 trig function problem. So we have to find sine, cosine, tangent, cosecant, secant, and cotangent. And I have to find the hypotenuse first. Okay, so I have to do a squared plus b squared equals c squared. So 10 squared, we'll call a. And I think in the problem it said a was 10, right? And the b they said was 5. Equals the c squared. So 100 plus 25 is 125. Remember, that's the c squared. So we have to take the square root. 125 to get c. Now, you should simplify that. You guys have done this before. Do your factor tree. It's 25 times 5. 25 is a perfect square. So we could write it as 5 for the square root of 25. And then the radical 5 is left. Now, what I also like to do here, since that's a 5, that's a 10, and there's a 5 there, 5 goes into all 3 of those. So I'm going to reduce it. Okay, I'm going to change it from 10 divided by 5 is 2. 5 divided by 5 is 1. And this 5 divided by 5 would also be 1. So I got radical 5, a 1, and a 2. That way, when I write my fractions, they're going to be in lowest terms. Okay, so I just do the same thing as number 1 now. Sine of theta. Opposite, here's theta. Opposite's 1 over hypotenuse square root of 5. And I have to rationalize. Don't forget that part. So 1 times the square root of 5 is the square root of 5. And the square root of 5 times the square root of 5 is just 5. That's what it should be. And then again, I like to do the reciprocals right away. So cosecant. Again, don't forget this part. Just flip the original. So radical 5 over 1 would be just radical 5 if you want. Cosine is adjacent to over hypotenuse radical 5. So again, I'm not going to show the work, but you have to rationalize. So 2 times the square root of 5 over 5. And then flip it for secant. So radical 5 over 2. Hypotenuse over adjacent. And then tangent, TOA. Opposite over adjacent. Opposite of theta is 1. Adjacent to the theta is 2. And then cotangent would be the reciprocal of that, which is 2 over 1. So again, I like to, if I can see a common factor for my 3 sides, I like to reduce it before, then I don't have to worry about reducing it later. So there's number 6. 1 and 6 are very similar. Okay, number 7 was a word problem. And it said this: a surveyor whose eye level is 10 feet above the ground determines the angle of elevation to the top of an office building to be 35.7 degrees. If the surveyor is standing 45 feet from the base of the building, what is the height of the building to the nearest foot? Okay, so over here's our building. I'm looking for how high it is. All right, so a guy, a surveyor, could be a girl, is 45 feet away from the building. The angle from where they're standing to the top of the building was 35.7 degrees. So there's my problem. Now remember, his eye level is 10 feet above the ground. All right. So there's, if I make this the ground, I got to remember to add 10 at the end of this problem to x. All right, so I'm looking at this angle here. This would be like my theta. I've got opposite side and adjacent side. The trig function that has opposite and adjacent is tangent. So I'm going to go tangent to set up my equation of 35.7 equals opposite x over adjacent 45. So there's my equation, and I just solve for x. And all you got to do, a lot of kids will just do this, make it a proportion, put that left side over 1 and cross multiply. 1 times x is x, and then tangent of 35.7 times 45. That'll be our answer. But remember, we'll have to add 10. So I use my calculator. So let's turn on my calculator. Okay, and make sure, make sure we're in degree mode. So let's get our view down a little bit. Hit the mode button there next to second. I'm in degree mode, so I'm good there. So I'm just going to go tangent, hit my tangent button, 35.7, close it off, times 45. And that's 32.3 feet, or to the nearest foot, 32 feet. But remember, it said in the beginning of the problem we had to add 10, or he was standing, his eye level was 10 feet above the ground. So remember, the building goes to the ground. So the x was the 32, but I have to add the 10. So I'll just write it like this then. Oops, get my pen back. That came out to 32, but then I have to add the 10 to get the right answer. So don't forget that part. So check that out. So the building's 42 feet high. It's not a very good 4, but you guys can see that. All right, so that's number 7, halfway done with this. Again, pay attention to those little details. That was 10 feet above the ground, that person. Number 8 says this: after takeoff from an airport, an airplane's angle of ascent going up is 15 degrees. The airplane climbs to an altitude of 8,000 feet. At that point, what is the land distance between the airplane and the airport? Round your answers to the nearest foot. So they want the land distance. The land would be where I got the x. Some of you may have put it x on the hypotenuse. That would be how the distance that the plane actually traveled. But from land, there's the airport over here. Here's where we're at right now. So we want the x there. So for this one, again, I have my angle. I have opposite side and adjacent. So this would also be tangent. So this one's tangent of 15 degrees equals opposite 8,000 over adjacent x. Again, if you make a proportion, you cross multiply, you're going to get tangent of 15 times x equals 1 times 8,000. To solve for x, you're going to have to divide by the tangent of 15 then. So this had like an extra step compared to number 7. All right, so I go to my calculator and put in 8,000 divided by tangent of 15. Close it off. And we get 29,856. And what is that? Feet, I believe, because it was 8,000 feet. All right, 29856. $29,856. All right, the last 6. Here's our little rules for 45, 45, 90, and 30, 60, 90. All right, 45, 45, the two sides will always be equal. It's isosceles, and whatever the sides are times the square root of 2 is the hypotenuse. In a 30, 60, 90, the side, the shortest one, which is opposite the 30, is my x value. Hypotenuse is always twice as long as that short leg. The longer leg is always opposite the square or the 60-degree angle, and it's x times the square root of 3. So whatever that side is, the short leg times radical 3 will be the long leg. Okay? So number 9, here's the picture for a 30, 60, 90. They gave you AB is 10, and you're supposed to find BC and AC, these two sides. Okay? So again, this short leg is always half as long as the hypotenuse. So you just divide by 2 and get 5. And then the short leg going to the long leg, we always multiply by the square root of 3. So it's just 5 times the square root of 3. I do not want the decimal. All right, I want it in radical form. 9 through 12 or 14 must be in radical form. No decimals, please. Okay, so that one's real quick and easy. All right. Now, number 10, you're given it this way. This 2 radical 2 is the long leg, right? So look at this number 9 here. I went from the short leg to the long leg. I multiplied by the square root of 3. This time I'm going from the long leg to the short leg, so I'm going to have to divide by the square root of 3. Okay? So this one would be 2 times the square root of 2 divided by the square root of 3. And then just rationalize it. All right, so 2 radical 2 times radical 3 is 2 radical 6. And then radical 3 times radical 3 is a 3. Now remember, to go from the short leg to the hypotenuse, you just double this side. So we're just going to double that. And all we double is the 2. So we go 4. 2 times 2 is 4 times the square root of 6 over 3. Again, no decimals, just put it in radical form. Number 11 is just like number 10. Should have made it different. But I'm just going from here, long leg to short leg, dividing by the square root of 3 again. So 5 radical 5 divided by the square root of 3. And then rationalize. And that's 5 radical 15 over 3. And then again, just double the short leg to get the hypotenuse. So just double the 5, and it's 10 times the square root of 15 over 3. So don't make it harder than it is. Just learn those, okay? All right, number 12, 13 and 14 are the 45s. So remember, these two sides on the 45s will be equal hypotenuse, and that's what we're looking for. For number 12 is hypotenuse, xz. All you do is take the side and multiply by the square root of 2. So you're finished. That's all you had to do. Only had one answer for 12, 13, and 14. All right, so number 13, I'm giving you the hypotenuse, and I want xy. I want this side. Okay, oops, get rid of that. Okay, so remember, when we went from this side, this leg, to the hypotenuse, we multiplied by the square root of 2. If we go from the hypotenuse to the leg, we do the opposite, divide by the square root of 2. And so xy would be 14 divided by the square root of 2. And remember, we got to rationalize, which is 14 times the square root of 2 over 2. But I can divide 14 by 2, so that is 7 times the square root of 2. No decimals, just radical form. And the last one. Okay, so I gave you yz, and I want xc, the hypotenuse. So you take a leg, and you just multiply by the square root of 2. So that'd be 5 radical 5 times the square root of 2, which should be 5 times the square root of 10. And it wouldn't reduce. So just 5 times the square root of 10. All right, so that's it for this practice quiz. I also post it written out in my better handwriting, like I normally do. I also am going to post the answers to those worksheets, 13.1 and 13.2, that you can look at if you want to do some extra work. But this morning, the quiz is posted, and get that done by tomorrow, please. Let's get it in on time. You guys have been doing a great job. Again, if you have more questions, I have office hours where you can conference with me. I haven't had too many people pop in to see me. I'd love to see you from noon to 12:30 on Mondays and Wednesdays, and 8 to 8:30 on Tuesdays and Thursdays. So again, good luck. Doing a great job. Don't hesitate to email me if you got questions, and have a great day. Remember, look good, feel good. You are good. You either get the bear or the bear gets you. Don't let the bear get you.